Hello, everybody, and welcome to our Chapter 14 test uh, review. I don't know, not really a test because I'm giving you all the answers, but it is the test because it's what you would take if I actually gave you a test. So, whatever. If you think back to all that we've done with Chapter 14 over the last 2 weeks, we started with points, lines, and rays. We talked about angles and measuring angles, parallel lines versus perpendicular or intersecting. And so this test is just going to kind of review all of that along with the shapes that we did this week, triangles, quadrilaterals, and then lines of symmetry. So let's just go ahead and get to it. Question number one, we need to identify the figure. Um, Now there is something here that I don't think I covered that well. So now's a good time to talk about it. If you notice here, and this is going to get really blurry when I zoom way in on it, but over top of this line AB, oh, why is it not drawn? Okay. And we'll make that black and thinner, maybe a little, maybe there. Okay. So over top of this line AB, you notice there's a line with two arrows on it. That's what tells us that this is referring to a full line, so never ending in both directions. Um, if you look at um, if you look at the line segment there, so maybe if I just zoom in a little further out, if you look at the line segment there, you'll notice that it is just the line. There's no arrow. Okay, so there's no arrow on either end of it. It's just the line over top of it. If there's no arrows, that's what tells us it's the line segment. And then a ray, remember, has one ending point, and one side that goes on and forever. It goes on in that direction infinitely. And that's when you end up with the ending point here and then an arrow on the other side telling you that that's referring to a ray. I don't think I covered that well in the very beginning, so now I have. So let's just continue on then. If we have this here, you'll notice we have an arrow on this side and an arrow on that side. Our line on top of our points there should give us um the same look. So if we have an arrow on both sides, that's representing a line. We should have an arrow on both sides up there that is also representing a line. Let's see what color should we use today. We'll use okay. So when I just start looking at A, okay, this is a line, which means line AB, not line segment, because that's both endpoints, but because I have arrows on both sides, and it's not a ray because it doesn't end on one side and keep going, and it's certainly not a point because it's a line. So this tells us that this is line AB. Okay, so if we look at number two, we only have an arrow on one side and we end on the other. Now remember, one endpoint and then going infinitely in the other direction is going to be a ray. So that one's going to be here, ray QR. Number three, if we want to identify what's going on there, we have two lines, line UW and line ST, and those do cross, so those do intersect, which means they are not parallel lines, they are not acute or obtuse, because they intersect at that exact 90-degree angle, which tells us that these two lines, because they intersect at exactly 90 degrees, are perpendicular lines. Number four, we have two line segments there. So line segment OP and line segment MN. And from the looks of it, they don't ever intersect. And if they continued on not intersecting, um, then we're left to assume the answer. So perpendicular means they intersect at 90 degrees. Acute means the two lines make an acute angle, which they do not. Intersecting means they cross somewhere, and they don't appear to, which tells us that these are parallel line segments. Number 5, what is the measure of this angle in degrees? Okay, this is going to require me to pull out my, um, yeah, the protractor. So let me get that brought in. Okay, and like magic, it's there. Video is awesome. Pause and restart. So go ahead and pull out, if you have the printed copy of this, go ahead and pull out the protractor that I gave you. But what we're going to do is we're going to put this on the dot and then on the line down there. Remember, the middle should be right there. And this one, if you notice, comes over and up. Now, when I scan this paper, it might be a little crooked, so hopefully that doesn't bother us too much. But you should be able to look at these and see that, I mean, that's not, if we measure from the 0, 40's right there, 60's right there, 180 is clear over here. So even if we're not exactly lined up, especially for the choices that it gave us, we should be able to tell that this is supposed to be a 90-degree angle. Now, if we come down here, we don't necessarily need the protractor to answer this one, but we're going to put it on there anyway so we can make the correlation. That is a 180-degree angle. Now, if a circle is 300 degrees, or 360 degrees, sorry, if a circle is 360 degrees, 90 degrees would be a quarter turn, 180 degrees is a half turn, and then the third turn and sixth turn we could figure out if we calculated. 1/3 of 108, or 1/3 of 360 would be 120, and 1/6 of 360 would be 60. Um, but we can also tell, just looking at this, that is exactly, like from one side to the other side is exactly half of the circle. So this would be a 1/2 turn. Okay, now if we come down here, find the unknown if the combined angle is 45 degrees. There's lots of different ways that we could think about this one. Okay, we could theoretically put our protractor on down here. And I'm really going to need that middle line extended some. So let's make that smaller, and let's just take this line and go whoop, so I can see better where it intersects. Now I could figure out, if I'm looking at line S, okay, that is at approximately, I don't know, somewhere in between 20 and 30. And the only one of these that's in between 20 and 30 is 25. We could also think about it, if we know that one of them is 20, and we know that something added to that, S, is going to equal 45, you can think about your fact families. If 20 plus something is 45, then 45 minus the 20 will give you that last measurement. Okay, so it's still that 25 degrees. All right, moving on to page 2. Which figure has only one line of symmetry? So this is really a matter of understanding those lines of symmetry and knowing what is going to cut these figures exactly in half. Rectangle has 2. Okay, the hexagon has a total of 12, because every corner and every halfway point is going to give you So 1, 2, 3, 4, 5, 6, 7, 8, 9. Or I guess that's only 6. Sorry. 1, 2, 3, 4, 5, 6. I don't count both sides of the line. But anyway, way more than one. The triangle from top down from all three corners. It looks like that's an equilateral triangle, so that one's going to have 3, which tells us that the heart being cut in half right like that is its only line of symmetry. The heart would be your answer for which one has only one line of symmetry. Which type of triangle is shown? We have the choice of right, obtuse, acute, or whole. I I don't even know what a whole triangle is. I mean, yeah, sure, it's a whole triangle, but that's not a type of a triangle that I taught you, so we can easily cross that one off. Your key here is this boxed corner. And if you remember, that box means what? That box means right angle. So this would be a right triangle. Okay? Identify the angle to the right. Now, you can look at it and see that it is greater than 90 degrees. I could pull my protractor back up here and show you for certain that yes, that is greater than 90 degrees. And if there is an angle that is greater than 90 degrees, we refer to that as obtuse. Oop, that's my... We refer to it as obtuse. So that is an obtuse angle. Identify the type of triangle by its angles. Okay, so equilateral tells me that all three sides are equal. That's not even identifying it by the angle, so it's not that. So is it obtuse, is it acute, or is it right? Well, does it have an angle that is greater than 90 degrees? And if you look right here, yes, it does, which tells us this is an obtuse triangle. Okay. Again, this one here looks like we have an equilateral triangle, which means all three sides are equal. It may or may not be, but that doesn't matter because what it wants to know is how many acute angles we have. And you can tell all three of those would be less than the 90 degrees, so that has 3 acute angles. What is the measure of this angle in degrees? Okay, so we'll bring this down. Oh, have that more right toward the center. Okay, so it comes along, comes out to the 0 here, points at approximately, it looks like. Again, my paper might be a little skewed from when I scanned it, but the only one that it's even close to is at 75 degrees. And then this question here deals with those turns again. If a whole circle is 360 degrees, which of those is going to be a 180 degree turn or half of the circle? That is this one there, because it goes half of the circle. All right, now this chapter did have a lesson on quadrilaterals, and for whatever reason, none of their tests test that, which I think is ridiculous. I do have about a minute left on this video, so I just want to take a quick second to review these different shapes. So we just kind of have that reminder. I don't have a ton of time, so we'll just go quick. The top one being a parallelogram. So this guy right here is a parallelogram. 2 sets of parallel sides, and that's it. I mean, we've got two acute and 2 obtuse angles, but to be a parallelogram, it just needs those 2 sets of parallel sides. This is a rhombus, which is again a parallelogram, 2 sets of parallel sides. The key thing that makes it different is it's got 4 equal sides. Rectangle, 2 sets of parallel lines, and then all 90-degree angles. So it is a parallelogram as well as a rectangle. A square is all of those, 2 sets of parallel sides, all 90-degree angles, and then all 4 sides are equal. And then our last little guy right here is what we call a trapezoid. That is your chapter. If you have any questions, feel free to reach out. Otherwise, have a good day.